With the bearing flats and the shafts now in place, I can go ahead and place the gears. I'm going to turn off the visibility of that front channel, make it much easier to view and to assemble the gears. I'm going to choose the smallest gear, the 12-tooth gear. This is the gear that will be driven by the motor. To assemble the gear, I'm going to look for the axis of the gear and then the axis on the bearing flat. So selecting the constraint tool and then selecting the axis on the gear. It's not quite as easy to get the axis on the bearing flat, so I'm just going to hover the cursor and then select the axis from the list. And apply that particular constraint. As I drag the gear out, you can see that the gear and the shaft are not properly aligned. So I'm just going to move that gear so it's easier to apply the next constraint. There's going to be an angle constraint between the surface of the shaft and one of the flat surfaces on the inside of the gear. And for the moment, that'll do. We're going to have to add one more constraint to the gear. The second gear could be either a 36, 60, or 84-tooth gear. I'm going to start with the 36-tooth gear as my first possible solution. That reduces the motion by 1/3, 12 teeth versus 36. So again, I'm going to constrain that by selecting the axis and then the axis on the bearing flat. So having placed that particular constraint, again I need to add a second constraint, which is aligning the gear to the shaft. Move the gear and add the angle constraint. With both the gears placed in the assembly, I'm now going to turn on the visibility of the C channel again. I need this to place the final constraint for both the gears. So I'm just going to rotate that around and apply the constraint. So it's the face of the gear and then the face of the C channel. Now you'll notice as I'm rotating this, it takes quite a while because it's a large object. If you simply click on the area you want to rotate, that makes it much easier. Select that face, and again the face of the channel. Now both gears are nicely placed in the assembly, but they're not aligned correctly. You can see that one's moving, the other one's moving, but we need to do some more here to fix that. And that's what those work planes are for. So let's rotate that around so we can see where the work planes are actually located. In this case, the work plane goes between the teeth of the gears, as does the one in the small gear. So I'm going to rotate the larger gear until I see the second work plane. And that second work plane goes through the center of a gear tooth. So now I can constrain those two work planes. I could use a mate constraint or an angle constraint. In this case I'm using a mate constraint. And with that constraint applied, the gear teeth are now correctly aligned. Now anytime I do that, I like to rename the constraint. Mate 41 doesn't mean very much when I come back to this in a couple of days. So I'm going to change that to align gears. So of course at the moment the gears can't move. I will be suppressing that constraint a little later on. You may also want to turn off the visibility of the work planes.